the front side of this handout together, so those are all the examples I have up here. So if you want it pulled up on your Chromebook, you can.
What are we doing, like, the other side probably?
We'll see. See how it goes. So, two things that I want you to remember with domains. In a fraction, the denominator cannot be 0. What's the denominator?
Bottom.
The bottom. So in a fraction, the bottom cannot equal 0. The second thing we need to look at is even radicals. So by that, I mean like a square root, a fourth root, a sixth root, and so on. In those, the radicand, do you know what a radicand is?
Which under the thing?
The thing under the radical has to be greater than or equal to 0. And so those are really the only two things we need to worry about. If our equation or our function doesn't have a fraction and it doesn't have an even radical, what do you think your domain is?
Those imaginary.
Everything. Domain is what you can plug in for x. If you don't have any fractions to worry about, if you don't have any radicals to worry about, you can put in any value for x that you want. So our domain would be negative infinity to positive infinity. If we have one of these two scenarios, then we have to look at it and figure out what our domain would be. So here is our first example. 3x squared plus 2x minus 1. We don't even need that. My directions on these are find the domain. So we're not solving anything, we're just finding the domain. Does this have a fraction?
No.
Does it have an even radical?
No.
So what is my domain? How do I write that?
Negative infinity.
I use capital D to stand for domain. So if it doesn't break any of the rules, it's just an automatic negative infinity to positive infinity.
I thought it would be like a problem.
The graph is.
All of the domain.
Yeah, if you think about your parabola, it keeps going forever in both directions.
Right.
You're thinking range.
Yeah.
All right, number 2. It has a fraction. What's my rule with fractions?
Cannot be zero.
What can't be 0?
Denominator.
The denominator. So the bottom, which is 2, can't be 0. Does 2 ever equal 0?
No.
No. So what does that make my domain? Alright. Okay, number 3. So we have a fraction. We know that in a fraction, my rule is the denominator cannot be 0. So what would you do here?
It can't be 3.
Right, if you add your 3 over x, cannot be 3. Now to write that, that means it can be anything except 3. So it can be negative infinity to 3, union 3 to infinity. I am still wanting interval notation.
Doesn't it matter if we do brackets or not?
It does, because if it's a bracket means equal to, and we said it cannot equal 3, so we have to have parentheses. Number 4. So I have a radical. So what's my rule with a radical?
Even.
It has to be greater than or equal to 0.
Right, if it's an even radical. You guys make sure you're with me on notes. Don't try to work ahead on homework. You'll have plenty of time. This is the square root, that's even, so whatever's under the radical has to be greater than or equal to 0. So x has to be greater than or equal to 1. How would I write that?
Negative infinity. No. Alright.
But you're on the right track.
1 to
Negative infinity. Yeah.
It's everything bigger than 1
So bracket at 1 to infinity.
equal to tells me it gets a bracket. So 1 to infinity. All right. Number 5.
Not too sure.
Thank you.
Really caught my attention.
So, what would I get? So 2x minus 3 has to be greater than or equal to 0. So if we solve this, add over the 3, divide by 2. So x is greater than or equal to 3 halves. All right, so then how would I write that as an interval?
Bracket 3 halves to infinity.
So now I'm going to start throwing some that have a few more pieces to it. How is number 6 different?
It has two things that can be 0.
The bottom can't be 0. If you have multiple things on the bottom, neither one of those can be 0. So x minus 2 can't be 0, and x plus 1 can't be 0. So if I solve this, I get x cannot be a positive 2 or a negative 1. The interval notation, when you have multiple things x can't be, gets a little bit annoying. Because if we think about it on a number line, we can have everything except -1 and 2. So it would be everything smaller than that, so negative infinity to -1. Everything between them, so union -1 to 2. And then everything bigger than 2, so union 2 to infinity. So it's a little cumbersome. My rule is going to be, if you have more than one value that x cannot equal, I am going to allow you to just leave it like this, saying x cannot be those things. If it's just one thing x can't be, like earlier we had x could not be -3, I want the interval. If it's more than one, I will allow you to just list them and say x can't be those. You're welcome. All right, I want you guys to try the next two on your own. So see if you can tell me the difference for each of these things. Number 7 had a fraction. Does the bottom ever equal 0? No, so what's your domain? We can run to the office and see what she has. Number 8, we have a radical, so we know the thing under the radical, which is just x, has to be greater than or equal to 0. So that would be bracket 0 to positive infinity. All right, number 9. So I have a square root, which tells me the thing underneath has to be greater than or equal to 0. Okay. Thoughts? Okay. What would you do?
Take the square root.
When you add a square root, you'd have to do plus and minus. What kind of number are you getting over here? An imaginary. So, if you think about this, this is just a parabola that's been moved up 2, right? We just found this thing never equaled 0. When is x squared plus 2 positive? Always. It's always above the x-axis. So there is nothing I can plug in for x that would make this a negative under my radical. So what's my domain? Right. Number 10. What do I do?
Solve.
We,
Oh.
right. We know the bottom cannot be 0. So to figure out what makes this 0, we can factor. We could take out an x. Bless you. So, what would make just a plain x?
4. Oh,
If you just have a plain x, what would I put for that? X cannot be 0. And what makes x minus 4 equal 0? 4. If you plug in a 0 or a 4, you get 0 on the bottom of that fraction. Since it's more than one value that x can't be, we're just going to leave it like this. Okay. I want you to try these two. All right, looks like 11 was good and 12 was not. So let's talk about 11. So you have the thing under the radical, greater than or equal to 0. So it would be bracket 9/4 to infinity. All right, how is 12 different? We have a radical and we have a fraction. So we have both things. So let's kind of talk about the two pieces. If you have a radical, what do you know?
It can be greater than or equal to 0.
Whatever's under the radical can be greater than or equal to 0. So that's the radical piece. If you have a fraction, what do you know?
Can't be 0.
The bottom can't be 0. Okay, so if you squared each side. So the radical piece tells me x has to be greater than or equal to 0, but this tells me x can't be 0.
So greater than 0.
So it's everything greater than, but not equal
Oh,
to
so that's
0.
the bracket.
So
Parentheses.
it would be a parenthesis 0, comma, infinity.
I had bracket 1.
I had bracket 0 too. Okay.
Yeah. And the only reason we couldn't have that bracket on the 0 is because it made the bottom of the fraction equal to 0. Okay, few more. I think I have
6
4
more.
more. Okay, so 13 is another one of those that has two things going on. So these are a little more complicated. We need to make sure we understand what's going on. The first piece, we have a radical. So I know that the thing under the radical has to be greater than or equal to 0. So if I subtract over my 1, then you would have to divide by a negative.
Yeah,
What?
flip it.
Yes. When you divide by a negative, it flips the inequality. So I get x is less than or equal to 1. Okay, so far, especially when you have multiple pieces that you're putting together, a number line can help. I know for that radical, I can only plug in numbers smaller than 1. This one, if I have a fraction, I know that the bottom cannot be 0. So x can't be negative 2. So it has to be smaller than 1, but I can't have a negative 2. So what I'm going to have to do is stop it at negative 2 and pick back up. How would I write that as an interval? We'll have to do a union. It's coming from negative infinity. We have to stop at negative 2, parentheses, because it can't equal. Union, pick back up at negative 2, and go until we get to 1. And the 1 gets a bracket. Do you guys all understand how I put those two together?
So you have to do the top and the bottom.
Yes. You have to check if you have fractions and square roots. You have to put both pieces together. 14, I have a square root, but what's under my square root? And we know whatever's under the square root has to be greater than or equal to 0. Isn't 2 always greater than or equal to 0? Mm-hmm.
Is it okay if we don't write the D for domain if we're just doing domain?
Yeah.
Is it okay if we just write all real numbers?
No. Interval notation.
The R is so easy.
I finally got good at writing that R. I used to not
I forgot once how to write all the numbers. It's hard to lose all the numbers on the quiz.
It's the 2 lines.
It's the double bar to R.
Well, now I remember.
Okay.
Used to in the past.
15. So this is another one that we have two different pieces. I have a fraction and I have a square root. We have to put the two together. So for the square root, the thing under my radical has to be greater than or equal to 0. So x has to be greater than or equal to 1. Okay, so that's what this piece means. Second thing, I have a fraction, so what do we know?
Can't be 0.
X plus 3 can't be 0, so x cannot equal -3. If you are already bigger than 1, can you equal -3?
No.
So what's my domain?
Bracket at 1 to infinity.
We found that it has to be bigger than 1, and it can't be -3. But if you're already bigger than 1, we don't have to worry about the -3. So we just have a radical, so the thing under the square root, greater than or equal to 0. So if I subtract over my 5, I have to divide by a negative, which flips my inequality. So x is less than or equal to 5/2. How do we write that?
Bracket of never mind.
Parentheses, negative infinity to 5/2.
Bracket.
Yes. So everything's smaller than the 5/2. So negative infinity to 5/2. What questions do you guys have for me? Do we need more of the problems where there's multiple things? Where we have fractions and square roots?
Not exactly.
So there's a handout posted on Classroom. We just did the first page, the 16 problems. There's 12 problems on the second page.